All right, cool. I think we're live. All right, let's see what Hacker News has. Avoiding homework with code and getting caught. Take on Dolby with new media formats. Adults still dream about school. Uh, we need new motherboards before GPUs collapse under their own gravity. Yeah, that's true. Two nights trying to do what Backstage does for free. That looks interesting. Facebook proven to negatively impact mental health. No shit. That's why I tend to avoid social media. What else we got? Hey Justin, what's up? Censorship by big tech at the behest of the U.S. government. I don't know. I don't care. I don't know. Slow day for news. Oh, Japan to reopen the independent travelers and lift daily arrival cap. Okay, cool. Time to go to Japan, guys. Wait, what? Strike crypto payouts. Okay, what the hell? Enable crypto payouts on your platform. Crypto payouts enable your platform to pay sellers in. Okay. Paying in crypto allows you to differentiate your platform, reach more. Oh no! Not like this, man! Not like this! Stripe, what are you doing? What are you doing, man? Oh no. When you opt into crypto payouts and provide your users with express dashboards, your users can link a crypto wallet with their account and set their US currency as US dollar DC. Your users can link a crypto wallet when they're first onboarded. USDC. Oh, no. Not like this, guys. Oh my god, I see so many issues. Okay. So, this is a really great way to blow up your liquidity. Holy shit. Holy shit. All right. So the first obvious thing that comes to mind is the volatility of whatever cryptocurrency you're using. So how do you know if something is worth X on one day and Y on another? Usually if it's like, if it's a normal fucking currency like the euro or US dollars, it's pretty close from day to day. But then when you can experience 5-10% drops or changes in the value of the currency, how stable is that? Not to mention you have time between settlements. So because of like how Bitcoin does like the ledger and whatever, basically Stripe has to hold liquidity until the payment gets cleared. And in that time, the value of the contract can change immensely. So imagine like locking up, like basically being wrong plus or minus 10% of the purchase price. Oh, geez, this is going to be fun. This is going to be one fun one to watch. I don't even think Stripe has a liquid amount of tokens to actually back this up. I'm thinking they probably partnered with like I don't know, like maybe Goldman Sachs on the back end to provide them liquidity for the transaction. I bet you that's exactly what's going on. This is pretty much what Klarna does. Like all the Klarna. What's the other one? The Affirm. Yeah, Klarna Affirm, and then I can't remember the last one. Basically, what happens with those services when you do like the buy now pay later model is that you're basically applying for a loan that some random fucking bank that they partner with is going to front the money for it, and then eventually that loan gets bought by Stripe, who then goes ahead either services the not Stripe but Klarna. Let's use Klarna, right? The bank provides the money for the loan that gets sent to the merchant, right? So that could be like if I'm buying an Apple iPhone. Now that loan actually does get bought and by Klarna, right? So Klarna receives the loan from the bank. In exchange, they lose some money. And then once that happens, what Klarna will do is package that loan with a bunch of other loans, and then sell it to like Wall Street in order and collateralize it. So the way you can think about the whole process is that okay, I'm buying an iPhone. Money gets gets funded by this random bank. Now, a firm will take some percentage of that price. You know, maybe 2% or something like that, or like somewhere around maybe closer to 3 to 5% really. And so Klarna will take that, right? And then Klarna needs to take the money, takes whatever capital they have, and then buy the loan from that bank. That bank is going to take some percentage of that loan in order because they were the one who provided the capital up front. So that's like 1% off the loan price as well. Now, what Klarna will do and a firm will do is they bundle it up with a bunch of other loans and then sell that loan, or they service the loan themselves from people. And those may or may not come with fees. I can't remember which one says they don't charge fees, but basically, once they take all those loans, they will then sell it off. Because within some of these loans, they will charge interest on it, right? So you can think of it like a junk bond, essentially. A junk bond is composed of a bunch of really like a bunch of loans rated from A, or like rated from like credit ranges. Like there's S, A, B, C, D. Yeah, S, A, B, C. And if you look at Ally Bank, they do pretty much the same thing, except they don't bundle and sell their auto loans. But basically, they rank it by, S might be above 700 credit score, and then A might be above 680, et cetera, et cetera. And they'll bundle all these loans together into some kind of fucking collateralized obligation, and then sell that off. And that's how they make money on that side too. So effectively, what you're doing is you're creating, originating, and selling loans. So that's basically how these companies like Klarna work. And so with crypto, think of it just like that, except now you're basically paying for instead of like buying and selling loans, it's buying and selling crypto payments. And all Stripe is doing is taking a percentage of that. That's exactly what's happening here. And the only thing is that, except that they're not paying out the crypto, they're just moving the crypto from one person's wallet to another, and that liquidity is backed by a bank. So honestly, whoever's backing Stripe, I would love to know. I would love to know who decided to fulfill the crypto payouts on Stripe's end. Let's see. Crypto payment Stripe bank. Let's see. Who is backing this? Is this let me see. Goldman Sachs. Oh my God! Ding, ding, ding! Ding, ding, ding! I knew it was Goldman! Holy shit. I didn't even know this one! Bank accounts with... Okay, they're offering bank accounts with Goldman Sachs and Citi. I bet you that Goldman Sachs is bankrolling the liquidity here. Holy crap. Holy crap. Goldman Sachs makes its first over-the-counter grip with Galaxy Digital. There has to be some bank. Okay, I can't confirm it, but I am 90% certain it's gonna be Goldman on the back end that is providing liquidity. Well, for one, the reason why I think this is one, if you consider that Stripe has a $100 billion market capitalization, or they probably cut it in the last 18 months because of what's it called, like the market downturn and whatever. So they probably took like a down round or down valuation. But the only company that's going to be sane enough to deal with like that much a market cap and therefore a exponential amount of volume transactions is going to be like a major bank, probably like the top 5 major banks. Like it'd be either BOA doesn't do crypto, Citi, but like Citi, God. Oh yeah, it's gotta be Goldman. It's gotta be like a firm like that that's engaged in crypto. And to my knowledge, only Goldman's like gonna actually fucking bankroll this shit. All right, let's bring my client on. Let's see what happens. God damn it! Stop logging me out. Hey, hello?
Hey, Everett.
Hey, what's up?
Hey, man. Going good. How's it going?
I'm doing alright. How is your practice going?
Good, man. primarily focused on recursion,
Okay.
like we talked about. I also revised the checklist for DSA.
Okay.
So yeah, that's definitely been helping. And for system design, looked at the replays and basically trying to avoid all those mistakes I made on our last session.
Mm-hmm.
Yeah, so focusing heavily on scoping, like we talked about. So
Yeah, scoping, and the other one was bulletproofing your approaches and whatnot before you commit to them. Like
correct.
punching holes. So you said you
Punching
revised
holes.
your data structure and algorithm checklist. Is that the one that's listed under 920, or do you have a new one?
I have a new one.
All right, can you here? I'll post it under 922. Can you paste it in?
Yes. One second. Okay.
Okay, so let's see. Did you read the problem? Do you understand? Did you go over examples? Did you understand bulletproof? Yep. Did you fully scope out the problem? What am I responsible for? What I'm not? Yes. Okay, so misinterpret the problem. Yeah. I would say if I'm doing this, I'm going to say misinterpret the problem and bulletproof kind of are the exact same question.
Okay.
It's similar. I mean, they're similar, but personally for me, I think I grouped them in because if someone can misinterpret the problem one way, then someone else can as well. And that's a pretty common way to like come up with like to start talking about two different things in like in a professional setting as well. So part of bulletproofing is going to be making sure that whatever the hell we're talking about and scoped for is going to be exactly that. So at least that's my instinct, but you may need to put it explicitly for now. But eventually, I think you'll get there. Okay, let's see. Handle examples. No, this is So do examples. You kind of again, you're repeating yourself. Go over the examples given. These are handle cases. This is very specifically for trees, but eventually with time, you're gonna also be able to figure out what constitutes complete testing. So the real thing here you want to say is, how do you know your testing is complete?
Okay.
Find all details. I'm not really too sure what this means.
Okay, yeah. This is going back to the example where if you're dealing with strings, make sure you know what your final string is going to be. For example, is there any lowercase or uppercase?
Okay.
This is finding all the details on what your answer expects.
I see. Okay, I'm going to tell you this is way too explicit for it to be in part like a checklist. This is more of something that should be in the back of your mind and instinctive.
Okay.
If you think about the checklist, right, it's like it should be very easy to follow, and you should give that checklist to anyone else, and they should do all right? So having like all these different questions, I'm going to say eventually it'll get narrowed down with practice, right? Some will say, this is like redundant and whatnot, but I'm going to say that this seems a little bit too specific for my tastes.
Okay.
Start with something that works. Simple case. Are your tests simple? Yeah. Again, it's kind of redundant from do examples and up here. It's a little bit redundant. So yeah, I mean you have a checklist. It's just beware of potential redundancies.
Okay, so when you're scoping out the problem, you also want to do examples too, right? Because when you're doing your brute force, you also want to do those as well.
Personally, I would just to make sure I understand exactly what it is. So for instance, I was saying, hey, yeah, are we going to handle negative numbers or not? Right? I might do an example with negative numbers if we are going to do that.
Okay.
But that's going to be a question that you're going to ask the interviewer first. Does that make sense?
Okay. Sounds good.
Yeah.
Okay. So that goes to like number 1 then and 2. So okay.
Kind of. Yeah. Remember, examples are really just the way of making sure you fully understand what the problem is, because there's talking about the problem and there's actually doing it. And the second one is that it demonstrates to the interviewer where you're thinking by giving something solid. I could give you I could just go on and on about like abstract concepts, but the moment I start putting pen to paper and the moment I start doing something, and in order to try representing an idea, it becomes a whole lot easier, right? The goal here is to eliminate as much empty talk as possible.
Okay.
And the examples can help you with that.
Okay. Sounds good.
Yeah. So structured, ordered, logical. This is the big one. Yes. Other person understand what the fuck I'm doing. Yes. Explain like I'm 5. Did you skip steps in logic? Do not skip steps. Yep. Ideal, optimize brute force solution. Find all inefficiencies. Top level. Describe top level idea. Why it exists. Did you talk about all the subroutines that will coexist? I don't know what this means.
So that's for example, like you're trying to find all the palindromes, right? In a string. You also have to list out all the functions. For example, there's going to be a function that's like is palindrome, right?
Yeah.
Because what I found myself is like I was leaving off those sub functions to the end.
Yep.
Yeah, so it would be like sub functions, not subroutines.
Okay, you mean like helper functions?
Yeah. Yes. Correct.
Got it. Okay, so I'm gonna say that's helper functions are not necessarily bad to leave out, especially if they're like very simple. Like for instance, like if I wanted to have like a reverse string function, that's very simple to do, and if I really focus on it, I can do it. Yeah. But for the purposes of like pseudocode top level planning, that's gonna be something I'm gonna leave off till later. But yes, you should identify what exactly each helper function does. But that should also be part of your naming as well. If you pick the right name, it'll be self-evident.
Okay.
So that's something you might want to keep in mind. So does your idea traverse handle all the way get past? Yeah. So this all the ways that your idea can be passed in. That's part of being bulletproof.
Okay.
Okay, and strengthening logical structured order. Yeah. Again, you kind of repeat yourself. So again, this is not bad for a start. But again, there's a lot of redundancies here. You could with practice, and the more mistakes you make and become aware of, you could get this down to half a page.
Okay.
So, but yeah, remember single responsibility and bulletproof and all that shit. So.
Okay. Yeah. My thinking here was like, okay, I really want to nail this down, so let me repeat myself. But yeah, as I go over, this will go away in one of the places, right? So yeah, it was just to like put it in my head and not forget it. So yeah, I'll clean this up. Yep.
Yeah, eventually with time, just as long as you're practicing right, eventually you will realize it on its own. So don't force it. If you feel like you need all of it, that's fine. Leave it there. But when you start practicing more and more and more, and you get more fluid with it, and you start making this more a habit, you'll realize you can't memorize all of it. I'll tell you straight up, if this was my checklist, I would only be able to cover like a quarter to a half of it. My memory is that dog shit.
Okay.
So. I think you have better memories than me. I do. I just have better instincts.
Okay.
So, all right. With that, let's. Is there a problem that you want me to look at? Actually, first, let me open your practice diary.
Okay.
Wait, hang on. Let me actually get a tissue. Okay, so. Okay, interview practice diary. Cool. Let's take a look. Any particular problem you want me to look at?
Yeah, I would say the generate strings of matching parents. Let me link you my problem log. 1 second. Yeah, so the ones I recorded, I guess we can go more in detail in those.
Okay.
Yeah. So yeah, I'll bring up the issue there. So.
All right. Yeah. Any of the strange ones. Okay. Let me take a look at the other entries in your diary here. Did you understand the problem thoroughly? Did you understand exactly? Did you go over examples? Your bulletproof? Yeah. That scope of the problem. What I'm responsible for. Yep. So this is like all the things we talked about here. Okay. So the problem really tested the example portion of my approach. Hold up. Give me a second. For the majority of the problem, I was doing example after example. Third miss on examples alone, complicated problem, mix in example code, talk about what I was doing. Yeah, so here, the red flag would be, hey, why am I spending so much time on examples? So I'm looking at the row 141. That's a pretty bad red flag, I think.
Yeah, with this one, I just got to the idea. I ran out of time and didn't get to code.
Yeah.
So yeah, it's too slow on the examples there.
Exactly. In other words, what I would look for in here is what order did you do the examples in? Why did you do which examples? And is there a way that you can make this more structured, or make it more efficient?
Okay.
Usually, when you throw 30 minutes of examples at a problem, it means that there's something illogical about the way you're thinking about it.
Okay.
Other person understand what I'm doing. Idea was explained at the end. Yeah. So in other words, you were able to come up with an idea. You just took too long to get there. So yeah,
Yes, yes.
this is where being structured and ordered would have helped you, and I would definitely recommend you try and figure that out.
Okay, okay.
Okay, start out with simple examples, logical and succinct. Yep. Um, yeah. So, oh, do not skip steps. Yeah. Brute force solution. Optimal was to do it iteratively with order one space. How to optimize reduce space complete. Yeah. So I'm looking at row 143.
Yep. Uh-huh.
And so whenever you ask yourself for optimizations, there are three ways you can do it, right? There's time, you can optimize by time, you can optimize by space, or you can optimize by code complexity. Those are the only three dimensions that you can really optimize against.
Okay, it's time and space. What do you mean by code complexity?
So for instance, if I have a million lines of spaghetti code that can easily be done in one line, that's an efficiency improvement, right?
Okay. Uh-huh.
So part of that is like, that's going to encapsulate like your refactors. That's going to encapsulate, hey, wait a minute, I might be able to write this a little bit better with, let's say maybe a for loop instead of me doing some weird shit with whiles and then assigning flags and whatnot. Sometimes that's unavoidable, but it's good to ask yourself that question. Can I make this code more understandable?
That makes sense.
Or is there like some weird code smell, or does this look a little bit way too complex and could be simplified? I think there's a lot of examples where EPI goes a little bit too far for this. They do like some really weird Python functions or whatnot. But for the most part, EPI does a pretty good job. Yeah. So in other words, the books, and so what you said is book starts with the root and goes down to left and right child's next set values. So yeah, so they're doing it at the same time, right?
Yeah, yeah.
You probably did it in 2 passes.
Well, I did it in a pre-order traversal because I wanted to focus on trees and recursion.
Okay.
So yeah, I did it in a pre-order manner where you're at the you do it in a pre-order manner, and then you check whether you came from the left or right.
Yep.
And that's how I would set the next level node.
Okay, that's fine. But yeah, you realize that the book does it with like order one space. You probably use order n space or something, right?
Yeah, exactly. Yeah.
Okay.
Yeah.
So yeah. So in other words, when you encounter a situation, you need to recognize, hey, I'm using order n space, and how do I use order one? So this is the next. That would be a question that I would put on your checklist right there.
Okay, sounds good. Okay.
So yeah, that's already screaming. That should already scream checklist. Add this because this is probably gonna be something you're gonna see again. Okay, and then you said generate strings of matching parentheses. Okay, so this is one you want me to look at. Misstating brute force solution since solution calls for valid parentheses. Did you call a brute force a naive approach? Derivation solution can be fast examples. Yeah. So it seems like I'm seeing a recurring theme is that the way you come up with examples is not efficient.
Okay.
That's the thing I noticed here. So
okay.
All right, so you want me to take a look at this one?
Yeah, it's in the problem log. Yeah, like the reason why on that one I didn't stayed out the brute force was because the problem description said give me all the valid parens, right? Because I could have said, okay, I'm gonna do a left and right paren here, regardless of whether they're valid or not.
Okay.
But yeah, I should always say the brute force there. So
it's just it just keeps everything structured so you're not skipping steps. Besides, calling out the brute force solution takes you like 10 seconds, and it's like a safety rail, right? It's like your seatbelt. Plugging in your seatbelt only takes you like 2 seconds, but when you crash your car, you're gonna be thankful that you spent the 2 seconds doing it.
Yeah. Yep.
All right, so yeah, did you send the replay?
Oh, okay.
This is the one you did the replay on, right?
No, I just did it in the problem log, but let me send you the replay once here.
Okay. Well, actually, if you did it in the problem log, let me bust that open. Let me take a look at what exactly you did. Let's see I opened your problem sheet. This last edit was 2 days ago. Yeah, I'm curious. I want to actually see like what your how you actually did this row 144.
Okay, let me send that in Zoom chat. Okay, yeah, I sent it in the Zoom.
Okay, let's see. Oh, okay. So you sent the two You sent the two replays and then the problem. Cool. Let's see. So you sent. Oh yeah. So you put in the problem log actually. Okay. Okay. There's another problem log. Okay.
Oh, it's the same one. Sorry. Yeah.
Ah. Okay. Generate palindromic decomposition. Is that it?
No, it's generate strings of matching parents.
Okay. Okay.
Uh-huh.
Generate strings of matching print. Okay. Cool. Okay. So you did an example here. Fine. Let me just compare it with your notes. Give me a second. Calling out the brute force solution. Sure. Okay, n equals 1. So you decompose it into 2 parts. Sure, why not? Okay, so calling out, you need to call it the very naive solution here. And okay. The thing is that what are you getting in? What do you get? So you're taking program takes n of a number and then it spits out all the possible combinations of closing parentheses. Got it. Okay. Okay. I don't see you calling out the naive solution, so that's where that first comes in.
Yeah, that's
Yeah.
in the note. Yeah.
And I think that's what caused you to come up with it. I don't fucking. What the? This is so long. God damn. Following talking out loud examples, left followed by right. Counts if counts the same. Sure. I can never have more than. Yeah, that's true. No way to make it valid. Sure. You're making a lot of observations here, I think.
Okay.
But none of them really come into a cohesive answer or logic.
Mm-hmm. Yeah. This is like me drawing on the whiteboard, like all the examples, all the possibilities, catching all my cases.
Okay. Sure. Yeah. So I'm going to say that you skip the step of, hey, well, let me try something very, very simple that works. Off the top of your head, what's the very, very simple thing that works? And you could probably write this in like less than 5 lines.
Yeah, just starting with n equals 1, right? Like, what can you output, right? You can output a left paren, right? And then based on that, what is your next step? You want to basically you have accounts for left paren and right paren, right? Because that's how many you have to output. So you have to say you want the valid paren, so the left has to become first.
Notice how you're rambling. I want you to really think about what you want to say, and you can describe it in less than 15 seconds.
Okay. Okay, so okay, so we have to come up. We have to. The final result is the final result is a string of balanced parentheses, right? So
what? How does that solve the problem? Again, just describe me your algorithm in 15 seconds or less. Really think about it. Like, I really want you to pretend I'm an interviewer at Google, and if you piss me off, pretend I had my wife is leaving me or whatever. Fuck, I'm not married. But imagine I'm like an interviewer at Google, and my wife's about to leave me, and I'm like, fuck, I'm like, just let me get on with my day. If you piss me off a little bit, you fail. You know. I want you to pretend you're in that situation. What would you do?
Okay. Okay, so okay, so initially you have your count of how many parentheses you want to output, right?
Okay.
Oh fuck.
Yep. Try again.
Yeah.
Really, like I said, really think about it. I don't care if you take like a minute or 5 minutes to think about it, but it's like this is gonna be a really important thing. So tell me when you're ready. I have a stopwatch here, so I can actually time you.
Okay, so okay, so my high level idea is to maintain a string variable and also the counts of left and right I have of right parents. Um, so at every fuck.
Stop. 15 seconds.
Yeah,
You
yeah, yeah.
notice how many times you just said Notice how
Yeah,
you're
I
declaring
fuck.
the variables. You're talking about variables and and all that stuff, but you haven't just told me what the algorithm is. This is just the basic core idea of the algorithm. No variables necessarily needed. You're talking about it in code. Oh, I have a string. Like, what the hell's a string? What's the idea? Why would this work? You haven't even told me how you're going to solve the problem, and you're talking about variables.
Yeah, yeah.
Focus on what the most important thing is. The most important thing is solving the goddamn problem. So give me the general idea of how to solve the goddamn problem. Like, I don't care if you use code. I don't care if you have to, like, make some, like, throw monkeys at the problem or whatever. I don't care. It's just, I want the problem solved. Give me the basic idea.
Okay, so the basic idea of this problem is at every step, you have to make sure whether adding a left parentheses or a right parentheses is gonna violate. It's gonna make your string in. Oh, fuck.
All right, let me take a stab at this. I'm gonna
Yeah.
time myself. All right, let me take a stab at
Okay.
it. All right, generate every possible combination of strings of length 2n with left and right parentheses. For every string, you're gonna do a validity check. Make sure there's an equal amount of left and right parentheses, and also make sure that the difference between left and right parentheses never goes below -1. That was 16 seconds. Okay, screw. And I'm just like doing it off the top of my head. Now, a follow up to that is, why does this work? One, because you're only going to look at strings that have equal amounts of left and right parentheses. That's one validity check, right? Why did I say the difference between left and right parentheses needs to always be greater than 1? Because if you go, left, right, and then you go right again, you can never come up with another left that would ever make it valid. So those are two basic checks you would do. Now, of course, there's like a lot of inefficiencies there. Like, for instance, if you're generating all those different strings, you're gonna be generating strings that have 7 left parentheses and 3 right parentheses. That's not gonna work. So we can instead of doing it generate ahead of time, we can generate on the fly and make sure that we have some counter or delta between the left and right as we go. That way we know whether or not we want to add more left or right parentheses, right? And so based on that, we can do the validity check as we go. So the more optimized algorithm would be, okay, we're going to make sure that there's going to be more lefts than rights at any, or there's at least equal or more lefts than rights at any given time. We will never be able to have a situation where, like I said, the difference between left and right is going to be less than 1. So we can never start with a right parenthesis, right? So we start with left parenthesis, that counter increases to 1. Then we have a choice between either adding another left parenthesis or a right parenthesis, because that will satisfy the delta requirement, right? And we'll keep adding, and we can add left parenthesis up until we reach n number of left parentheses, after which we're forced to add right. And once the string gets to a length of 2n, we submit it. That's the basic algorithm. That's the basic idea. Of course, that's high level, but I can fill in the exact details. But I'm pretty sure the book does something similar.
Correct.
Yeah, and I did that without but notice there, all I did was take a very simple idea that I came up with I described in 16 seconds, which you immediately understood, and I addressed, hey, why is this right? Why are the checks right? And I just said, hey, let's incorporate that into a better, into the algorithm. That's it. Now, of course, I can always flesh that out a little bit better, but but notice there, like, even you understood very, very intuitively what the hell I was talking about.
Right.
So you need to be able to do that. Nowhere did I really talk about like variables. I just kind of derived at a high level, and then just kind of, I just more or less described the generalities of it, for lack of a better word.
Okay.
This is approximately what it looks like. I don't know if I'm going to use what variables just yet. I just know that I need to do this. And you need to basically do exactly the same thing. So I would recommend that as an exercise. You're not allowed to start writing pseudocode or code until you can describe the problem or idea in 15 seconds or less. Let's add that to your checklist, just as an exercise.
Okay.
Okay, so I'll put that here.
Okay.
So I really want you to do this for like your homework, and
Okay.
you practice that muscle, and of course you like you might need to start recording yourself, and then playing
Okay.
that back. It's
Sounds.
like, does that even make sense?
Okay, that makes sense. Okay, yeah,
Okay, because I noticed that this might be one way to fix the example problem, because I get the feeling that you can't you whenever you do like a lot of these problems, you actually don't know what you're doing, and so you get it confused in your head, and so you just try to aim randomly at examples, and eventually you kind of somehow meander into the solution.
yeah.
That's the sense I've been getting from our past sessions. So I'm going to suggest you really focus on that.
Okay.
And just to make sure that you do it, make sure that you write this in your diary. So like if whatever idea that you had or the way you explained it, write out in your diary entry. Like 15 seconds is like what, less than 30 words. So it's not going to take up that much space, but it will let me see and you let you see whether or not what you said makes sense.
Okay.
All right, with that, let me actually see your... Okay, so now you did that, let me see the rest of the problem. Okay, save... Okay, so then let's form an idea. Start by having left parentheses that you need to fulfill. At each step, we'll analyze the L count and right count. Yeah. Dealing with left parentheses. If L count equals right count and count equals 0. Yep. Sure. Why? Okay, idea at 31 minutes. Yep. Yeah, so you basically, what I'm seeing here, the mistake is that it sounds like you started off overcomplicating it and you didn't come with a brute force idea. This one kind of works, but there's a lot of other things that you need to test for.
Correct.
Like when I said we're brute force, since the problem asks for a fast solution, not always good. Always make sure to call it brute force. Yeah, brute force Yep. So let's see your solution. This is this right here. Is this the book solution or your solution?
That's mine.
Okay. So you have n times 2 to the n runtime? Okay, interesting. Yeah. Okay,
Yeah,
so
it's wrong.
left count equals right count, and left count equals 0, and right count equals 0. Yep. Yeah, that's fine. And then left count is less than right count, and left count is not 0. Add left parenthesis. Yeah. So if left count is less than right count, and right count is not 0, then add the right parenthesis, and then you decrement the number of right count. Yeah, I think this one pretty much looks right. But yeah, I don't think... I think this looks like the optimal solution, right?
Yeah. The brute force is like generating all the possibilities of left and right.
Yeah.
And then what they do is they run it against the stack to see if it's invalid. Then they'll exit out, and they'll only output the valid to the answer.
Okay. But yeah, I think your answer is also optimal, no? So.
Yeah, correct.
Okay. Yeah, but it's pretty much exactly what I said. You just did left count less than right count, and instead of the delta. So.
Okay.
But notice I didn't even look at your solution. I just kind of came up with it off the top of my head. Basically, think of brute force and the optimal one.
Right.
Okay. Anyway, let's see your.
Yeah, man. The one quick question on this one is they had like a really confusing time complexity there. So I don't know. I guess I just have to practice more math on this because it was really confusing. It's at the bottom below the yellow highlight.
Okay, so you said that this is order n runtime or order 2n?
This was my answer after I did the problem, but it was wrong. The right answer is down here below, where it says EPA for recursive has
factorial. So holy shit, yeah. This is, so when I see permutations like this, I'm thinking, okay, this is combinatorics, right? This falls out of it. K is the number of parentheses, right?
Correct. Yeah.
Oh, I think this is like the notation, like what's it called? You have what's it called? N choose. What is it? You have 2n choose n. That's what it looks like to me. Or in this is 2k choose k.
Okay, yeah. It's one of those.
The reason why is because you have, like I said, you have like for every. Let's suppose let's use k just for the sake of consistency, right? K is going to be equal where k is equal number of left parentheses. So based on like generating every single possible combination permutation of left and right parentheses, right? We have a total of 2k slots, and we only need to pick half of those to put the left parentheses. The other half is going to be for right parentheses.
Oh, okay.
That's why. So this is just a combinatoric one.
Okay, that makes sense.
Yeah.
Oh, shit. Yeah.
So this is going to be, I would say, choosing combinatorics notations are going to be really, really important. Personally, I would not memorize this. I would just memorize this notation. I'm like, okay, well, that's my runtime. I don't remember the factorial. I think most people would be happy with that, actually.
Okay.
Like, yeah, don't worry. You know what you're doing, So it's not practicing math. It's like thinking about what does it really mean.
Okay. That makes sense.
Okay. All right. So let me take a look at your what's called the replays. So the first one or the second one?
The first one, what is it? Yeah, the first one is a Sudoku solver. Yeah, the first one works.
Okay. Let me download.
Yeah, I think that's the one I spent the most time on. So. Yeah.
All right. Is there anything you want me to pay attention to?
Specifically talking about like being logical and driving each thought to your idea.
Yep.
Yeah.
Okay, let me share my screen.
To solve a Sudoku puzzle by filling empty cells. Sudoku solution must verify
all right, cool. VLC.
Each of the digits 1 through 9.
All right. So you mostly want me to take a look and make sure that you're being logical and rational about your problem. Do you have a diary entry for this one by any chance?
Oh, shit. Let me see. No, I just have the problem log for that one.
Okay.
Let me see what I wrote down. 1 second. Yeah, it's also like yeah. Please take a look on like my example. See how can I improve those as well.
Sure. Okay, so you have Sudoku solver. Satisfy all the following rules. Yeah. Okay, got it.
Must occur exactly in one column. In each column, each of the digits 1 through 9 must occur exactly one of the 9 3x3 sub boxes. Okay, so that's 1 through 9 in this box. 1 through 9. Okay, so reading the problem, everything is straightforward.
Okay, so you're starting at 1.
Scoping it out, everything looks good. Okay, so the brute force solution, what can we do? We see that there's values already filled out. So for every empty cell, and then from definition, it has to have 1 through 9. Fill in 1 through 9.
Oh, dear.
And save all possible combinations, taking advantage of our constraints above.
Okay, good. So I like so far so good. This is the right brute force solution. Just like spam 0 on all of them, then 0 1 0 1 0 1 0, and then 0 1 2. You get the idea. That's basically what you just described, right?
Yep, correct.
Correct. That's perfectly fine as a brute force solution. It doesn't take that long to explain. I think everyone understands it.
Okay, so for that one, should I waste any time writing it down, or just explain it at a high level?
Explaining it at a high level and writing it down is basically, well, if you think about it, for the purposes of the replay, writing it down, I would prefer you write it down. But when it comes time to the actual interview, you don't need to write it down.
Okay.
I'm only making you do this as an exercise.
Yes. Okay.
Because it's like one thing to say it, it's another thing to actually write it out. And if you write it out and you have that practice, it makes you like realize, wait a minute, that whatever the fuck I just said doesn't make sense.
That makes okay. Yeah.
So, all right, so that's fine. Okay, so so the fuck are you doing here? Hold up.
So you can try 1 through 9. These are all the possible choices you can make. Okay. Then there's a constraint you have to apply after you've done your choice, and this is telling me whether it's valid or not. So it's so if I have a choice and I have a constraint, and then I can have my result. So we're gonna have to take advantage of backtracking here because there's many choices possible. So let's take the happy case where you choose a value 1 through 9. It's valid. That particular cell is filled out, so you continue and you fill out another cell.
Okay.
Let's take care of the not so happy case where it's not a valid choice because there's another 3 in the same row. Sure. So what do I have to say? through 7, you're gonna
Got it. Okay. All right. So you're trying out the example just to make sure that you straighten it out in your head. Okay, fine. At each empty cell, you try numbers 1 through 9, and just make sure you check validity constraints. Okay. And then advance to the next cell. Okay. The interesting part is that it takes you actually quite a long time for you to go. You notice that you basically went from 5 minutes to 15 minutes just doing this?
Yeah.
What happened here? I mean, I don't want to spend like 10 minutes just like picking it apart, but this must have been something that caught your attention when you looked at the time.
Yeah. So it's basically running through the examples and what's going to work for this problem. Because I noticed as I was doing the examples, at each cell you have all these choices, right? Then you have your constraints, and then you check it if it's valid or not, right? And if it's valid, you keep recursing you keep traversing the board. And if it's not, you have to erase that value and continue with your choices 1 through 9 that you have. So it was just me like trying to get this clear on my head and trying to figure out like the idea that's gonna work.
Okay, so this you trying to shotgun in the dark. I think I have a better way of thinking about it. Is that if you acknowledge that, hey, I am generating a bunch of dog shit solutions that obviously don't work, I can just test it as I input it.
Mm-hmm.
That would have been much faster.
What do you mean by that? It's just going over the example, glossing over the example?
Yeah. The reason why is because I think that idea alone already kind of explains itself, right?
Yeah.
So that would have been better. And and so instead of you trying like random examples to try and come up with the idea, if you just thought of it from a optimization perspective, top down, and you thought about, hey, what the problem falls short on, and you just kind of went from there, you end up not only being faster but a lot more structure in your thinking. Mm-hmm. So this is I think this is an example where you try to shoot randomly in the dark to try and find an optimization. Mm-hmm. So that at least that's what it looks like to me.
Yeah. Okay.
So in other words, it's like you come up with a brute force solution, but then you abandon it to try and find something better. It's like, okay, yeah, you're gonna abandon it, but there's something in it that works. You need to keep the thing that works and cut out all the fat. That's what really should happen here.
Okay.
So that's gonna help you be logical and ordered in your thinking. It's like, where is this idea coming from?
Here initially, I place it in the board.
Hello?
I check if it's valid. Okay,
yeah. Okay. So that's something that's I noticed that was a thing in your past coaching sessions as well. I couldn't tell where ideas were coming from. But if you can at least say where the string of ideas are coming from, that helps you be logical and ordered. So make sure you tie each step to the previous step in some way, or just say, hey, the previous step was pretty dog shit, and I'm going to backtrack and whatever, like at least acknowledge the past efforts and how it feeds into your future ones. That's going to that's going to help you.
Okay.
Okay, so fine, here, traverse. Okay, so.
If we talk about is valid saying, it will check the constraints that we have defined here on our problem statement.
Okay, sure. So you're defining your is valid state. So you traverse row by row.
Yeah, this is where I define like the top level helper function. Yeah, and I say I would come back to it though, because all it is checks the row and then it checks the column and then it's gonna check the subgrid. This is if it violates our constraint.
Sure, I think that's fine. Okay. Now do what? Okay, I don't mind you writing it out. Okay, then you go from 14 to looks like 22 minutes. That's what happens, right? Okay, that's fine. I would prefer you like you're just trying it out. Okay, fine. It looks like it works, but the question now is, what is the inefficiency here? Or do you think this is the most efficient you're gonna get?
Yeah, the only optimization there is checking if it's valid, right? As far as being more efficient, I couldn't think of another way.
Okay. Instinctively to me, Is you're repeatedly checking a row over and over and over again. That's kind of like what it looks like. That's the most inefficient thing, right? So if we go to your
Oh,
example, the example
okay,
that the book gives you, it's like
okay.
this 5 3 7 row, right? Let's say I add a 4 in here, and then the next one I'm looking at 6, right? I'm constantly going to be looking at 5 3 7 5 3 7 5 3 7 over and over and over and over again.
Mm-hmm.
And then same thing with the cell, right? If I add 5 3 6 9 8 over and over and over again.
Mm-hmm. Mm-hmm.
So the way I would have probably thought about it is, okay, well, if I have to keep checking this over and over again, why don't I instead come up with a pool of numbers per square that of all the possible things that it can be, and then as I select each one, then I will eliminate it from row, column, and cell.
Okay, okay.
That's probably the way I would have done it.
Mm-hmm.
And so, um, instead of like trying to grow it, I would have, like I said, there's like the invert heuristic, right? This is a great example of it.
Mm-hmm.
At least I wonder if the book does that actually. How does the book do this?
Sure.
I'm actually curious now. Hold up. Where is the Elements of Programming interview? Sudoku. Okay. Okay. Let's see what the brute force solution is to try every possible assignment to empty entries. Yep, they announced that. Good. This is wasteful.
Mm-hmm.
Right? Apply backtracking principle. Yep. Traverse 2D arrays one at a time. Entries empty. We try each value of the entry, see if it's updated, still valid. So the next paragraph, however, we can reduce runtime considerably by making use of the fact that we are adding a value to an array that already satisfies the constraints. This means that we just need to check just the row, column, and subgroup of the added entry. Okay. No, actually, they do exactly what you just did.
Okay, okay.
Yeah.
But yeah, that's a good optimization where you called out there.
I mean, to be fair, you're still doing effectively the same thing. It's just that the runtime might change based on how densely populated the Sudoku code is. So
okay, okay.
I'm gonna say that my solution might not have been the most optimal if I think about it a little bit more. But that's like the first instinct that jumped out at me.
Okay, okay.
But it seems like they did exactly what you just did. So yeah, so it basically takes you 21 minutes to get there. 22 minutes. I think if you so the question now becomes why did you spend so much time? Okay, so I'm seeing that it takes you 8 minutes to go from one
For
step to the next
example,
one.
you're initially on that. Oh, and then there's 2, 3 here, right?
Okay.
Okay. Okay, so I can try numbers 1 through 9. I can try 1 here initially. I place it in the board. I check if it's valid. What I mean by valid is I'm going to check all the rows, I'm going to check all the columns, and I'm going to check the subgrid that this cell exists in. So all those 3 checks are going to have to check the values 1 through 9.
Okay.
If there's multiple values, that means that it's invalid. So if I place 1 and then I check my constraints, that's going to tell me that it's invalid. So I have to pop off. So then I'll try 2 again. I can try. So here I can try the numbers 1 through 9 again.
Okay, I see.
I did spend a lot of time talking about like the backtracking and how that would work. Yeah, I still like a good 5 or 10 minutes there. So.
Okay. I think you're overdoing it a little bit. So the thing about the examples is that the way it works is that if you have an idea, then you use examples to prove it, right? That's one direction you could go.
Yeah.
Another direction you can go is try a bunch of examples and then look for commonalities. That's the other direction. The first one is much more preferred than the second one. The reason why is because it's a lot more structured and ordered. If you just try a bunch of examples and just look at what works, that's a strategy you only use when you have no fucking idea of what's going on and you're just trying to shoot from the hip. But I would argue that if you followed like the whole, how do we become more efficient, you wouldn't ever have to shoot from the hip. You wouldn't have to try shotgun it. And I think right now you're just kind of shotgunning it. That's what it looks like to me a bit.
Okay.
Yeah, that's what it looked. Yeah, so I think if you just like followed that, and just went to the. Yeah, you cut down by a few minutes here, but as far as completeness goes for what you were in, this is fine. It's just that I think you could be a lot more efficient about your time.
Okay.
So and then now I was doing this. You're You're coding. You're doing a pseudocode.
Yeah, I also wasted time doing reducing this from like a 9x9 board to a 3x3 to be quicker with the examples, but that got complicated, so I wasted some time there too.
Okay, and then you're spending. So it took you like 15 minutes to code it. Why? The fuck? Okay, so you're 26. Oh no. Oh, don't tell. Okay. So the thing is that you had the idea and then you wrote the pseudocode twice, it looks like. If I'm not mistaken.
Yeah, I just wrote it down to copy the code, to do the code actually.
I see. Yeah, I get it. Okay, I see where the time's lost. Yeah. Again, what you're doing is not unreasonable. It just needs to be more. It just needs to be more efficient.
More faster. Okay.
It just needs to be faster. I'm not saying to skip steps. Well, some steps can be combined. Some steps are redundant.
Mm-hmm.
So
okay.
I would recommend you rewatch this replay, but because to me, because you know we have time, I need to look at the second one. But to me, it looks like a lot of shit is like repeated. So if I look at between the 22 and 40-minute mark, that's 18 minutes where you really don't like say anything different. That's the thing. I would recommend you look. Yeah, you look at each time. I'm sure if you shave off like 3 minutes at each part, like the first chunk where you come up with the brute force solution, second chunk where you come up with the more optimal one, and then another like 3 to 5 minutes chunk. But at the between the 22 and 40-minute mark, that saves you like 10-15 minutes. So that reduces the 40-minute problem into a 25-minute problem. So it's just like, just look for those savings where you feel like you might be repeating yourself, not adding any additional value, where you don't feel like you were increasing understanding. Every single word that comes out of your mouth needs to accomplish something. Everything that you do needs to accomplish something. And if it's not accomplishing anything, then, or if it just feels like it's redundant and doesn't create new information or understanding, chances are you can cut it out. So I would recommend you rewatch this yourself.
Yeah, for sure.
Okay. So yeah, at least you have the basics down. So it's just being more optimal about it. Let's look at the next one. Is it the decompositions one, right?
Pal decomposition.
Got it. Let's take a look.
Okay, generate palindromic decompositions. You have a string here. Okay, so you have a string. You decompose it into 3 parts from this example.
Okay, so palindromic decompositions. What the hell does that mean?
You want to take the string. Excuse me. The point is to break down the string where each substring will be a palindrome.
Okay.
And then return all the different combinations at the end.
Okay, why is 611 space 11 and then space 6? Why is that? Is it because I don't understand that one.
Oh, I think that was me iterating over the string and trying to see how they were coming up with their solution.
Okay, got it. I don't understand why 61111 and 6 is a solution actually. Is it just because there's a 1-1 in there?
Let's see. No, that's just my mistake with the examples.
Okay, so you're going to decompose the string into all possible palindromes. Got it. Okay, I see.
Correct.
Got it. So let's see what you do here.
It's a palindrome.
Yeah, so you're doing it. That's fine. I have no problem with this. Trying to understand the problem, how it works.
One. I'm still at 1.
Good.
I'm still at 1, right?
Okay, I have no problem with what you're doing so far. I think this is perfectly acceptable. It's saying, I have no idea how to solve this. Let me try some examples just so I get my bearings. Oh, I noticed that this can be decomposed. Okay. Alright, but I think they're... Okay. So you're coming with some solution here. Check if the substring is a palindrome, the string you've seen so far. Add the string to current results. Okay. Let me see how far you go with this. I think so far everything looks kind of reasonable here. So far, like, I don't have any gripes about what you're doing, actually. Let me see.
Yeah, I think I copied it again to start the coding, I believe.
That's fine. Like, 12 minutes coding is fine. Uh, uh, what the fuck happened here? Yeah, keep iterating. Okay, that's fine, yeah. The thing is that this little thing I'm looking at between, like, 14 and 16 minutes, this should have been addressed.
Okay, okay.
If you look at it, all you did was address the happy case, and then you realize, oh wait, I need to address the sad case. So you broke your rule of like bulletproofing.
Okay, okay.
So it's like if it is because it's binary, right? If it's so far the substring so far is a palindrome, then you will do X. But what if it isn't?
Correct, correct.
Okay. Yeah, so you immediately identify it's recursive too. Yep, I think this is right. This looks right to me. And then you're testing it out fine. Yeah, okay. The only thing I would say is that instead of trying to shoot from the hip a little bit here, I would have also verified. So, like, when you're generating the example here and you realize it can be decomposed,
Okay.
I think it's a little shooting from the hip. I would have tried oh yeah, let me try every single possible way of chopping up the string, and then realize that the way I chop up the string, some things might not be palindromes, and then you would realize that you only chop them up once it is a palindrome, and then each one of the palindromes themselves can be decomposed.
Okay,
I think
okay.
that adds a little bit more structure to your thinking, and it might have helped.
Okay.
But the key insight that you had of going for each palindrome can be decomposed is correct. I think that's the big insight that would help you solve this problem. So it's good that you discovered that insight, but I would definitely want you to be more structured because if you think about it holistically and think about what you just did, you kind of just end up stumbling upon this insight.
Yeah, missing the case where it's not the palindrome. Okay.
Yes.
Okay.
So,
yeah, that makes sense.
Yeah. So in other words, you would need to be able to break these up into palindromes, and each one of the palindromes can be decomposed into a string, decompose the palindromes themselves. And so then you would be able to, like, if the substring so far was palindrome, then you add that to the current list and then decompose it, and it basically becomes a factorial problem, combinatorics. Wise, again, like what you did here is not necessarily wrong. It's just I would like a little bit more structure to it.
Okay.
Because also, like, again, you broke the bulletproof thing here. Is palindrome current?
Yeah. Yeah, I was like, okay, what's gonna happen here if it's not a palindrome? So yeah, that's doing the example there. Yeah.
You should have tried punching. Remember, this is the punching holes heuristic.
Okay.
So you missed that. That's a big one. I would definitely want you to try and figure that out again. Okay, you're trying that out. Okay, Ron. Okay. My question. Let me see if the book does. I think your answer is right. So let me double check with the book. Did you check with the book?
Yeah, I did. Let me see.
Let me see.
It's been a while. 1 second.
Okay.
Yeah, they get quite Pythonic on this one. So
which what's it called? Which problem?
15.7 in EPA.
Okay. I'm looking at the Java version. Damn. Okay. Hold up. The title of the problem is palindromic string.
Or... generate palindromic decompositions.
Generate Oh, got it. Okay. Yeah, they do. Yeah, it looks like your solution is pretty similar to what they did. Let me double check. But yeah, you should double check this yourself as well. Okay, so if length equals, yeah, you're right. You've got the return though. After results appended, you forgot that.
Oh, okay. Oh, shit.
Because you have an answer, right? So just break out of it.
Yeah.
And then, yeah. Okay, the next one offsets the prefix. I is palindrome prefix. Yeah. So okay, that's fine. Yeah, it looks pretty much right. Yeah, so
Okay.
good job on that. I think it just cleaned up a little bit more on the structure.
Okay. Okay.
And I think I think it's pretty okay to get this in 30 minutes. Although personally, yeah, I try to aim for 25, but I'm not too dissatisfied with this one, especially considering that you got to 25 minutes, and then you added 5 minutes of testing. So that's actually okay. Yeah. Yeah. Again, this is probably pretty good. If you did this in Google, I think you would probably get probably a 3.5 or 4 out of 5.
Okay.
Yeah, the way you get 5 out of 5 is if you explain this logically, like smooth like butter, and got this in sub 25 minutes, which is the second part is very difficult to do. I can tell you that. I don't think I would have gotten in sub 25. Believe me, 5 out of 5 is really fucking hard nowadays.
So I guess that's like how fast you are, right? To get like to 5, right? That's what it sounds like.
Well, the thing is that don't focus on the time. Focus on having an efficient and good approach. And then the speed is just a consequence of having a good approach. So I think the thing we're really working on here is having a logical structure and order to it. And again, because you kind of stumbled upon the insight, I think that hurts you in the long run. During this problem, it was good, but that's the thing. You can't really judge how well you solve the problem, how well you approach the problem by the results. Over a long period of time, as you keep doing more and more problems, the nature of your problem-solving approach does reveal itself. But for one or two individual problems that you did really well on, that's not enough to say whether or not your approach is good. Like, if you did well on one or two problems, but you sucked ass at 99 other problems, that probably means something's wrong with your approach, you know?
Yeah.
Obviously, there's always things that can be better, but we don't want to make things better just while sacrificing stability. So the thing here to make it more efficient would be to, like I said, the top-down approach with a brute force solution, then recognizing the decomposition, recursive nature of these things. And then also bulletproofing as well. I think that if you would have saved yourself 2 minutes actually if you bulletproofed it by saying if so, if not.
Correct.
And then also the return one as well should have. Yeah. So it's a lot of small things, but I think you're gonna save yourself 5 minutes between all of them. At least that's my instinct.
Okay.
So it's like make sure so I think one of the other ways you can think about it is like the case. Remember by cases. The end case here is like, hey, what if we're at the end of the string? No point. Just add it to the result. Return. No point in going forward. Think about what each case means, and then just cut it off.
Okay.
So that's the way I would think about it. I otherwise I think this is a good sign, but I'm cautiously optimistic.
Okay. Still needs practice, so.
Yeah, I mean, again, the bulletproof. Remember, what can go wrong? Did I cover all the possible cases? And this is a very good example of how you kind of just missed that. And I think like I said, if you caught that, you would have saved yourself 5 minutes. Time. Any final questions?
Okay, so for what do you still want me to focus on recursion for EPI, or is there any other chapters you want me to look at?
EPI. I think for now you really need to get used to the idea of bulletproofing, because remember what I said.
Okay.
The system design interview and the instruction algorithm interview, your approach is going to be pretty similar, right? The question that you ask yourself, bulletproofing, scoping, everything. I think, and plus we didn't really focus too much on this so far. So I think, like I said, split your time half and half between each. And if you find yourself running out of system design problems, go back over the old ones and try to make, and finger crossed that you don't memorize the solutions and just apply your same what's called checklist to it.
Okay, that makes sense. Okay.
Yeah.
Okay, cool. So that sounds good. I'm also gonna take a look at like the leader principles stuff and all those stories. Yeah, because what the recruiter told me is like I did well on those, so I'm gonna recycle some of those stories. So So for next Friday.
Okay. So let's do this. We're on week 4 right now. Give me an update on like the recruiting situation actually for Amazon and Google.
Well, the interview's next Friday for Amazon.
Okay.
For Google, I haven't given them a date, but you said aim towards like October, early November.
Yeah, I would say towards third week of October. I think that's probably where we're aiming at. But if Amazon's next week, we can go over your stories on Tuesday.
Okay, sounds good.
All right, cool.
Okay.
Yeah.
And will we meet Thursday, the night before the interview, or?
I would want to, just to make sure that handle any last minute
Okay.
jitters, any questions that you might have.
Okay.
But personally,
Perfect.
for me, Thursday, I usually that day before an interview, I usually try to decompress a little bit.
Yeah.
So I
Yeah.
recommend you do the same.
Okay. Yeah. Yeah. Okay. Yeah. I'll be around. Sounds good.
All right. So
Okay.
all right. Cool.
Cool. Awesome. Thanks, man.
All
See
right.
ya.
Thanks. See ya.
Thank you. Thank you. Bye.
All right. Any final questions from the crowd? It looks like it's a little bit light tonight. Going once, going twice. All right, well, I guess that's it. Thank you all for joining me. We will be back here on Tuesday, 8 p.m. Pacific Standard Time. We'll be going over his progress over the weekend and more or less more coaching. And hopefully we get to see how things progress. Thank y'all for joining me. If y'all join me in the Discord and tweet at me, links are in the description below. And if you guys also want to be coached as well, you can book me for interview coaching at echantech.com.